For this next example problem, we'll be analyzing a diverge segment, which is located close to the beginning of my facility. So if we zoom in, it's going to be this left-hand diverge off-ramp to I-94 westbound. As we can see here on the slide, we have all the required input data. Before we dive into the modeling, I want to just quickly discuss how we are modeling adjacent ramps for this particular example. You may notice here at the left side, this is a left-hand ramp, and the immediately ramp located downstream is located on the right side, because the adjacent ramps are used to compute the vehicular flow that's located on the ramp influence area, or in this case should be the two leftmost lanes. We are going to skip this right side ramp, and we're going to consider only the next ramp, which is a merge, because this is located on the same side. So always keep that in mind when looking for adjacent ramps. And with that, we can open our Freeways module and we can start our modeling process. We can start a new file, start a new Diverge segment, and then let's start our modeling. We have 3 lanes in this Freeway segment with 1 ramp lane. My measured free flow speed is 71 miles per hour, 35 miles per hour ramp free flow speed. We can keep this length as 1,500 feet. Let's make sure we remember to set this ramp side to the left. I have level terrain. Because I know free flow speed, I don't need to change the other inputs. Here I have a deceleration lane length of 250 feet. And here I should be done with my geometric inputs. Next, let's focus on our demand data. And here I have my freeway demand, 3,759 vehicles per hour, with a diverge demand of 225 vehicles per hour. We have a peak hour factor of 0.97 for both the main line and the ramp, with 17% trucks on both main line and ramp. We don't have any adjustment factors to apply. We have all familiar users. And finally, we have a downstream merge, as we discussed, located 2,630 feet downstream. We have also level terrain with my downstream ramp demand of 385 vehicles per hour. And again, I have a peak hour factor of 0.97 and 17% trucks, and no upstream ramps present, so I can just skip that part. With that, we can go to our segment report. Similar to merge analysis, we have the freeway data on the leftmost column, the ramp data on the rightmost column. Here I have volume to capacity ratio under 1 for both cases, so everything should be good. My service measure here, density in the ramp influence area, is 28.8, which in this case would give me a level of service D. And with that, we have concluded our diverge segment analysis.